This question is on numbers. The question says n is equal to a to the power 4 plus 4 to the power a, where a is a natural number. For how many values of a is n a prime number? Now by putting down the values of a as, let's say, 1, we get number is equal to 1 to the power 4 plus 4 to the power 1, which is 5, which is a prime number. Now putting n is equal to 2, a is equal to 2, we will have n is equal to 2 to the power 4 plus 4 square, which is not a prime number definitely, as this is an even number, and the smallest prime number which is also even is 2, so this is definitely not 2. Now putting a is equal to 3, we will get n is equal to 3 to the power 4 plus 4 to the power 3, which is equal to 81 plus 64, which is 145, which is definitely not again a prime number. Putting n is equal to 4, we will have a is equal to 4, we will have n is equal to 4 to the power 4 plus 4 to the power 4. So 4 to the power 4 is 256 plus 256, which gives us 512, which is again an even number. So looking at the pattern, we see that whenever a is even, n is definitely composite. This is not prime because it's going to be an even number. So we need to put a is equal to odd values only. Now putting odd values, it may be a prime number, it may not be a prime number, so we cannot concur that for for values of a up to very large values up to infinity, how many prime numbers we can get. But one thing is there, that if we rearrange the values of n in such a format that this is equal to something into some other thing where both of these are natural numbers, then one thing is for sure, that this natural number has got two factors, at least two factors, the third factor being 1 and n itself. Once we are able to prove this, we can definitely say that n is not going to be a prime number. So we need to write this expression as something into something. The only way of doing this is by writing n as a to the power 4 plus 4 to the power a. Let's make a perfect square from here. So this is a square plus b square, plus this will become 2ab, so 2a square and 4 to the power a by 2. Now since we have added this, we need to subtract the same value as well. So the first one becomes a square plus 4 to the power a by 2 whole square. The second part becomes 2a square 2 to the power a. Now this is of the form a square, this is of the form, let's say, x square, this is minus, if we can write this in the form of y square, so we'll have x plus y into x minus y is the factorized form of x square minus y square. So our motive is to write this expression as y square. So let's do some rearrangement, let's simplify it in that format. Now if you bring this 2 to this 2, we will have a plus 1, so this becomes a square 2 to the power a plus 1. Now in order to make this as a perfect square, we can write this as a into 2 to the power a plus 1 whole divided by 2 whole square. So this is the form x square minus y square, which can be further written as a square plus 4a to the power by 2. This is a x plus y, so this is a into 2a to the power a plus 1 by 2 into x minus y. So now looking at the power of 2 over here, we can very much say that a has to be an odd, such that odd plus 1 by 2 will not give us a fractional value. Now since a is going to be a natural number, this expression is also going to be a natural number into this expression also going to be a natural number. So we can definitely concur that this n has got at least two factors, 1, 2. The third one being 1, the fourth one being the natural number itself. So for no other values of a, we will have any number prime except for when a is equal to 1. So the right answer is A.